So this week we're going to talk about code style. Normally we'll do debugging first and then coding style, but I want to get this across earlier in the course because I want you to think about code style while you are coding and think about debugging after you have coded. So let's do code style first and then debugging next week. Why does code style matter? The primary reason why we care about code style is your code that you wrote has to be easy to read, either for you or for your partners or for your TA. The code is going to be read many times, modified many times. Therefore, your code needs to be maintainable and often not by the original author. And even if it is by the original author, you will likely not remember what you did when you first wrote the code. After you have wrote a lot of other code in the same project as the project gets larger and larger. So the goal for code style is we want to make the code that's easy to read and understand. And this really helps with debugging. If your code is hard to read, it's going to be hard to debug. It's going to be hard to modify and it's challenging for reuse because you won't want to use any code that's too hard to read. So we're going to cover some guiding principles, and here is a list of all of the aspects of coding style. Your TA will be checking for all of these after you submit, and you should keep all of these in mind. We're going to go over the important ones one by one. Guiding principles. When a human is reading it, there is a cognitive load that's constrained by human brains. Human working memory is 7 plus minus 2 items at a time, and this is 2. So when you're writing this code, after your function have more than 7, more than 9 variables in scope, you'll start forgetting some of those and you'll have to constantly go back to where you declared them. And trust me, that's true if you haven't encountered anything like that. So try to minimize the number of considerations while you are writing the code. And this will really increase your productivity. So in your code, it should explain why on itself. When you're reading the code, you should know why this code was written in this way. If it's hard to do, you should be writing the why either in the variable declarations, in the comments, in all of things like that. So original writer usually knows why. Sometimes even the original writer doesn't know why after they do other functions and then coming back to it. But it should be easy to understand both for the original writer and for your teammates and for TA. These are the guiding principles. We'll be introducing each of these important things one by one. First one is functions. We want to make our functions short. And by short, Google gives this number 40 lines or less. We are not going to place a hard constraint on that. You can do so internally in your group. We are going to only check whether this function can approximately fit into 1 or 2 screens. If it's going to be more than 2 screens, like you have to scroll down by 2 times for a single function, this is too long. And your TA will deduct marks for that. Long functions are hard to read, understand, and maintain. So If you have a function that is too long, you will lose your patience while reading it. You will forget about something that's before it when you're writing it, or there are a lot of things like that. So try to avoid that. Shorter functions will force you to name parts of code so that it's easy to read. It will force you to organize or structure your code to reduce the number of duplications, to reduce the number of copy and pasting that's happening within your code. And your function will grow over time, even if you have a small function at first, like your load map. And then each time when somebody in your group adds a short global variable, your function will grow by at least 5 lines each time. It will be longer than that. And you will have at least, I'll just say, if you have 10 global variables, this will be growing 5 times, 5 lines. It's going to be larger than 5 lines, 5 to 10 lines for 10 global variables, and that's going to grow above this number, way above this number. So organize, structure your code as you write, and you don't want to go back to your code and see a really long function, then refactor it. As you write your code, if you see something can be factor it out right away. So yeah, your function will quickly grow too large, so refactor to extract new helper functions if this happens. So then you can save 5 to 10 lines into a helper function, and in this specific function, just 1 line of calling that helper function. Yep. Yeah, you're recommended to make more functions. And smaller functions is easier to maintain because some operations might be performed multiple times and you don't want to rewrite it every time. That's functions. Then variables. There's obviously the variable namings. Good variable names describe the contents and purpose of this single variable. By looking at the variable name, for example, you should know whether it is an intersection ID, a street segment ID, or a global variable, or a constant, so that the reader doesn't have to go back to the declaration or initialization every time it sees this variable. That's naming. As for temporary variable and scope, remember we want to reduce the cognitive load every time when you're reading through your program at each timestamp. You should be minimizing the number of variables in scope so that you don't have to go back to its declarations to know why did you declare this variable this way. So if you can use a temporary variable, use it. Just try to minimize the number of variables that are more global, unless absolutely necessary. But also be mindful of temporary variables. Only add them that help with readability and add information, because we don't want your code to grow. So yeah, we're going to cover examples for each case. Okay, let's see. This is a function that does a really common function. So can everyone read it and tell me what this does? I'll give you 1 minute. See, this is a relatively short function and there's not much to it, but it's really hard to understand, right? It's really normal if you can't get what this is in 1 minute because this is written with really bad variable naming. Now, if we change it to this, the only thing I did was changing the variable names. So what is this function doing? You don't have to go into details, just tell me. The what? The area. The area below the graph, and what is that called? The integral, right? Yeah, this function is called definite integral, so it's computing the integral of some function. What it does is it breaks this portion between x1 and x2, so x left and x right, into small chunks of step size of 0.0001. And what it does is it sums the area of each small step size by approximating the rectangle before the curve. And which function is this? Hard to see, right? This is 1 over x. 1 over x. But it's hard to see just from variable namings, but at least this is better than this one, right? And if you look at this one, the variable names are actually making sense. It's just really hard to understand for a new reader. Yes? Question? No? Okay. So the variable names are actually making sense. This is di for definite integral. We have the a and b if you're doing an integral from a to b. And there is the d that is the step size. And mathematically, d makes sense for a small step size. And all of these are making sense. But when you're writing this program, write it like this. So that whenever a new reader comes to it, it's easier to understand. That's the importance of variable namings. So general naming conventions for variable names, you have to start with a lowercase letter. That's the global rule for variables. It has to be made create the descriptive, often multiple words, and you can discuss amongst your group to choose whether you want to use underscores or camel case. I would personally choose underscores, but it depends on your group. And also, after you decide on one of those, do not mix the use of those. If you decide on camel case and if the TA sees some underscore ones somewhere in your code, they will say this is inconsistent. Constants, you can either make it start with K and use camel case, or you can make it all capitals. I would personally choose all caps because this is really clear that this is a constant or a global constant. Type and class names always start with capitalized letter and camel case. And this is why I would recommend underscores for variable names because we want to differentiate between this and this. But if you start with a lower letter for camel case, it's fine. So yeah, just keep to this rule while you are writing your code. All right. This is a sample piece of sample code from one of our functions. Any thoughts in terms of coding style? The first thing always when a TA checks your coding style is, do you have the right vertical spacing? So your vertical spacing has to make sense. But this one, there's no vertical white space, so it's really hard to read because you need commas when you write a paragraph, you need paragraphs. When you're writing an article, because you want to know when to pause, when to go to the next section. So we want to break into paragraphs of related code so that you only have to worry about the single paragraph when you're reading. And this is exactly the same code, but adding vertical white spaces. And now, how about variables? Let's think about the scope of the variables. There are many function scope variables declared up here. Do they have to be up here? So there are this 3-segment info, and this is only used here. There is the distance first, distance last, that are only used here. There's the length that only used here. So we actually don't need those much function scope variables because they're either used in if or else. This will lead to potential initialization bugs if you're not declaring whenever you use them. So we want to then declare variables at the smallest scope possible where they can be initialized at once. Because when you are declaring something at the top, you might forget that you initialize to something, or you might be assuming that you initialize it to something, but you actually didn't. So we want to initialize it whenever you need to use it. We already see a shrink in the code size, code length. So we're declaring length right when we initialize it. We're moving all of the more code into else. And how about variable names? Are the variable names good? No. Why are they not good? They're not descriptive enough. ID here doesn't say which type of ID it is. Inter 1, inter 2, they are losing the information of from and to. And there are redundant temporary variables. Lat long 1, lat long 2, inter 1, inter 2 are redundant. So potentially these are creating more confusions and we want to remove that. We want to use descriptive variable names to avoid temporaries which do not improve clarity. So we rename ID to street segment ID. We rename info to segment info, right? For clarity. And we then remove the need for from and to by combining these two and these two. So we can do lat long 1, lat long 2 directly from and to and get intersection position. So see how we combine those. And then we have to rename the lat long 1, lat long 2 to be descriptive of whether it's a from or to. So we do position from, position to. And we can then further reduce the double length because it doesn't make sense to have two lines here. They can be perfectly fine to combine into one line. So here we have shrinked this if statement from a long paragraph into 3 lines. Now we see there are temporary variables pause from and pause to. Do we need to do this? From and to, do we need to combine them into the single return statement? No, and why? Yeah, this one single return statement becomes too long and really confusing. So sometimes temporary variables improve readability, adds information because we call them pause from, pause to, and we can say find distance between 2 points, pause from, pause to. That's much clearer than what we have here. And more lines will allow you to see your steps in the debugger. So here, this is a single return statement. In your debugger, you'll have to first jump into get intersection position seg info.from this function, and you have to jump out of it and get into this one, and then jump out of it and into this one. So it's too confusing to debug. So if you just keep all of those on different lines, it's going to be much easier. So we went from before to after. Everyone sees the difference. So we went from something really confusing to something really clear. And we didn't even add in comments. Right. So, comments. I would suggest write comments as you go, because if you write your code and add comments afterwards, it's going to be harsh and you'll get annoyed. So write comments means you write down your thought process as you go. Before even attempt to write the code, write your comments. As a TA, what we'll be checking is we are checking different types of comments. If you look at the header files, at the beginning of the header file, there is this huge chunk of block comment that's describing what this function doing, what this file is doing. Before each function, there is a few lines that describes what this function does. Before each struct or class, there is a block comment describing what this is and how you should use it. Then inside your code, for each code block, there is one line describing what this block does. This should be familiar to everybody. You should be reading through the code and noticing this pattern. Which ones are the most important? Just in your experience of reading through the code that we provided, which ones are the most important? Yep. Look, this one? Actually, yep.
Before what the function is doing, description.
Description before the functions?
Yeah.
So you're really detail oriented. So you go to the details first and then go to the higher level. Whenever you open a source code file, the first thing is always to check the higher level comments. And then you can go into details afterwards. So what we value the most is the high level comments. We want to see documentations in the comments. So we don't want a separate document for documentations. We want everything inside your code in the comments. And this is because if you keep the comments inside your code, whenever you do a modification in your code, this forces you to change the documentation. You don't want any documentation to go out of date. The most important comments are the ones that gives the big picture. So in front of each big file, you need a comment block saying what this file is, how you should be reading this file, and where you should go first in this file. And then you go to the classes data structures. And remember, these also have big chunk of block comments before them, because usually understanding the data means you can understand the program. For example, if we take the function we wrote last week as an example, so we ended up creating a global variable that stores a vector of vectors and we're returning it. So you should be having a block comment before this global variable saying what is stored in this global variable. And by reading that, you'll know how your code is structured. There is something that's at the beginning when you open the map, you're populating this, and when the function is called, you are returning from this. And reading the data structure first will just imply all of those. And especially for skilled programmers like your TA, this is the things that value the most for them. Then declarations of functions, how to call the functions, what it does, and for tricky code for each of the code block. So these are ranked from the most important to the least important. So when you first start writing the code, you might start from putting in line comments for each of the code blocks. But as you get more proficient at writing code, the higher level becomes more and more important. Because the higher levels are just like table of contents in a book. You don't want to go into line by line in the book. You want to go to the table of contents first, find what you're looking for, and then you can directly jump to it. So this improves your performance by a lot. Now, Something do not do. Do not leave commented out code in your project. If you need a record of something, Git has everything. And that's it. That is also why do not try to hard reset your Git history because you might erase something important. And do not translate clear code to English, like what you would normally do for some primary coding lessons. You might be doing declare integer and then integer a. That's just too clear to be translated into English. We want to keep it short and concise and understandable. Let's get back to this integral function. We knew that this is integral of some sort of function, but adding in comments. Let's read through it. Before this function, we added 3 lines of comment saying compute the definite integral of 1 over x between x left and x right via the trapezoidal method. And it also says smaller values of step size improves accuracy but increases computation time. That's the amount of detail we want for each new function you write. The first line tells us what this does, how this does it, and the second sentence tells us why did we make the choice of step size equal 1e to the minus 4. And if we want to reuse it and we want to change it, what should we change? We change the step size. Then, let's see, inside this function, we only added 2 line comments to it. And that is the density of line comments we want. For these ones, we do integral, step size, x1, x2, y average declarations. We don't really need a comment for that. For initializations, we don't really need a comment for that. Inside this for loop, we're doing starting from left to right, increment by step size. This is clear enough to not have a comment to it. We increment x1 by step size and we check whether x2 is greater than x right. Right. In case x right minus x left is not a multiple of step size, we do x2 equals x right. So we clip x2 to x right when it's not a multiple of step size. So this is fixing one of the corner cases. And because we're fixing one of the corner cases and it's hard to see from just reading the code, we want a line comment beside it. And then we compute the average. And this is something that's too important. We need a line comment beside it. And then we do the increment to the integral and return. The most important comment is the comment about what this entire function does. And then we comment any tricky bits of code. Good. Everyone knows how to write comments. In past years, I've really seen a lot of students ignoring the higher level comments. They have some functions without block comments before it. They have some added new header files without any block comments before it, and those are sources of losing marks. And having these higher level comments also helps you. You will forget what you did before, like one day before even. So trust me and write comments as you go. Duplicate code. This is something we really want to avoid, and it's also part of the coding style that check that we will do. Avoid duplicate code. It's likely going to be extracted into its own function, and extracting some code into its own function means giving it a descriptive name. And by looking at it, you know what it does. It was likely copy pasted by the programmer from somewhere else. If there is one bug in one of the copy pasted code, and you fix that one bug, but you didn't fix that one bug in the other cases, which is likely going to happen because you won't know all of the places where that piece of code is copy pasted into. So let's do it with some example. This is an example of something that you will most likely do. So in this one, let's just spend some time reading through it. We do segment ID. We loop through all of the street segments. We get the street segment information. And we're making sure the ID is not a duplicate for the SSID from intersection ID. And we do two almost identical code blocks. And we know if some code blocks are almost identical, we can extract them into helper functions. And this is more readable because we just say insert unique intersections, street segments from and to for this street segment ID. After this, how about the comments? Any comments on the comments? Yep. Comments are repetitive and we don't really need one single line comment for a single line. And it's a bit wordy and repetitive, so we went from this make sure the ID is not a duplicate, and this line is actually not making any sense. So we change it into this add street segment if it is not a duplicate. This is higher level. It describes two lines, and we know why we group them together because it's the call to the same helper function. All right, I'll show you some IDE tools for code refactoring. So I would recommend everyone taking coding style in mind when you're writing your code. But after you wrote all of your code, you have to do a code review together with all of your teammates to make sure everything is consistent. And in case something is not consistent, you will need some. These are just options that you can use to really simply refactor. So let me move this over. I will show you the code first. So this is the same code as last week when we did this find street segment of intersection function. So we have this global variable, and mind how we're putting the comments here. And these comments are really not complete, but you'll have to have something similar to this. And this function. This is the only function we implemented in this code. And all of the others are stop functions, empty functions. I will go to Makefile. And I hope everyone's already gone through this. Configuration, I'll choose release first. Build target, I'll do all. Try not to do a single one of these, just choose all to be safe. And launch target, it doesn't matter for milestone 1 because we're doing auto tester anyways, so I'll make, I can do a clean configure, I'll do a build clean. So there's no build errors. I can go to the terminal and I can do ECE297 exercise 1 -- run tester. I want to run the functionality intersection test only. And we'll see we're passing one of the 3 tests. And now let's go back to the code. This larger. Any comments on this function in particular? Because the other ones are single lines. Yep.
And no vertical space.
No comments, no vertical white spaces. So I'm not going to add comments for now. I'll be just adding vertical spaces. And anything else? How about indentations? These 2 for loops are not indented properly. How to fix this in VS Code? There's something that's really convenient when you highlight, right click, and format selection will format it for you. But just be careful, and also this one as well. Format selection, format it for you. And just be careful if some of your group mates decide to use the opening bracket on the same line, and the formatting will force it to another line. So if you want to be consistent, just try to either just follow what format selection does or just manually make them onto the same line. I would personally prefer them on the same line, but VS Code defaults to on the next line, so it's up to you. The only thing we care is being consistent. I'm not adding comments for now, but any comments on the variable names? Yep. Yeah, num, I, and x are not explanatory. And something really convenient in VS Code is when you highlight num and when you do rename symbol. This is really convenient because it will realize all of the num in scope. It will not replace all of the nums in the file. It will only realize this variable in scope and it will only rename that one. So you won't have to worry about changing something by accident. We just want to rename all of the num in scope. So we rename this into num intersections. Press enter. And we see all three of those are renamed. And I want to rename rename symbol. This will only rename the variable I, so it will not touch the I for intersection, I for int. It will only rename the variable I. I will do intersection ID, right? And X is not descriptive. Let's rename X into num sec at intersection. Something like this. And I'll rename J just because I saw it. That guy. Yep.
Descriptive is done. Like,
Uh,
you can't have things like I and J, but you could.
if it's an intersection ID, I would suggest naming it to intersection ID. If it's, I just want to make sure that the seg_i is, like seg_i is more descriptive than J. Even if you do I underscore S or something, I underscore seg, it's going to be more descriptive than J. But we won't be too harsh on that. As long as it's easy to understand, it's fine. All right. I renamed everything. I formatted the selection, and now another thing we want to make sure we do is for load map, we don't want load map to grow indefinitely long, so we want to refactor chunks of code like this into functions. And it's hard to do that in VS Code without having to download more extensions, and we weren't able to get it working. So for VS Code, you'll have to do it by hand. Let me see, is there anything else for VS Code? All right. So if you want to rename something, this is just a text editor thing. It's going to be not as smart as right-clicking and rename, but this is something you can use. So you're at this intersection ID, Control D will select all of the intersection IDs. Control D. Again, it will add a cursor to the second one, and you can modify both of those. This is just a convenient text editor command. And this is just Control D, Control D, Control D. And more Control Ds will highlight more. And then you can change them. Like this. This is a text editor command. It's not smart. Just, yeah. Something useful that you can use. Now, I will just prove to you that this does not change functionality. So I build it, then I run the test. And we still see this test is passing. All right, that's that, I will revert this file and I'll do the exact same thing in NetBeans. And I use this %, just to make NetBeans run in the background. So you can continue using this terminal. When it's in background, you can have FG to move it into foreground. And then you can press Control Z and then type back BG to make it back into backgrounds. Just the useful thing in the terminal. All right. Let's go to IDE demo, libstreetmap, source, m1.cpp, and to the same position. We want to rename num. What we do here is, this is the same functionality as VS Code. We go to refactor, rename. And this will rename all of the num in scope. Sorry. Num intersections, refactor. This does exactly the same thing, and we can also rename the X. Refactor, rename. X is num street segment of intersection. All right, and so J. Refactor, rename J into seg_i. Rename I into intersection ID. And then format. There is a same functionality here for format. We can just highlight and click format. And we see in NetBeans, the format is defaulted to this opening bracket to be on the same line. And for VS Code, it's on the different line. So watch out for that. And everything else is the same. And now, we want to refactor this code block into a single function. We're not able to get it working on VS Code, but in NetBeans, there is something in refactor introduce function. And this is actually doing more than we want, so. Introduce function. Yeah. We want to check that we actually are not going to get any parameters. The return type is void. We name this function populate or fill. This global variable that is intersection, street segments. We give it this name and we click refactor. So we see the code block becomes one single line of call to this function, and we introduce this function like this. Questions? Yep.
Recommended to keep a population study in both math, like we did like last tutorial, or
You should be filling everything in load map, but we also want to constrain the length of the function. We don't want the function to grow bigger and bigger.
Data structures can be popular, but like, if we can make it shorter, we can make, like.
We can make short helper functions. Yeah.
They can't be super long. Okay.
Your load map is the one function that will get super long. So doing this, we can know that when each global variable is populated. If you just keep all of the code inside here, you'll have to search for when each variable is populated. And in this case, you can do it by grouping different things together. So grouping will make your code more structured and easier to understand. Any other questions before I move on? I'll take that as a no. The next big thing is use constants, not magic numbers. Everybody will try to sneak in magic numbers somewhere in your code. Do not do that unless it's as obvious as a 0 or nothing else. Nothing else. Any thoughts on this code? And because we're looking for magic numbers, which numbers are magic numbers? And because we have a high level comment up there, so you'll know what this code is doing. Yep. The 20 is a magic number. And anything else? The -1, 0, and 1 as return values are coming from nowhere. And you have to know the code pretty well to know which number we're looking for. So magic number 20, we want to, if we are changing the array size, we must find and change all of the 20s. And if there are other 20s in your code meaning something else, you might be also changing that and causing problems. So we're also returning magic numbers -1, 0, and 1. We must read the code carefully to find out what each means. So what we would recommend is use named constants. In here, we're introducing 3 ways of naming constants. All of them will work. I would like you to either use constant int or define. So try not to mix use of them without any reason. So the first one is a constant variable. We named constant int num weights equals to 20 at the beginning. Usually define weight 0 is a preprocessor constant that uses the define flag. And usually people will lean towards using this. And this one usually is reserved for like storing something from the return of some function that you are not able to modify. So usually we want to reserve const to enforce that something cannot be modified. So if you want to define a constant, usually people will choose to use this one. Now the second one, enum, weight return. This just gives the names to -1, 0, and 1 that has some meaning. And this enum is actually a enum type. And inside it only has three numbers, -1, 0, and 1. So we can use these ones like this. And then the return, you can also change int to enum wait return. This is a valid return type, and this means integer but constrained to only the values defined here. So this will force the program to crash when you try to return something that's not within the range, which means something's wrong. We always want the program to crash before it giving a wrong answer. Because if it runs correctly and it gives a wrong answer, there is nothing you can do to other than debugger to find out where it went wrong. Yeah. Yeah. Uh, wait. I think I think it's used more for integers. You can check whether it works for other types. Integers will definitely work, and you can assign any type of integer to it. I've never seen doubles. Yeah, and I've never seen why you would need to use doubles. So yeah, you can try it. I'm not sure. I'm not 100% sure. Okay. Any questions on constants? We still have, yep.
Are those globals, should they be put at the top under, like that, and then you use them inside your functions?
That's a good question. So for enum, this can be made global or it can be a field of some class or struct. Define is always global because it's compiler. Const can be local. And it can be made into a temporary variable. Yeah. Now, I will show you a demo now. To warning demo. Let's open this file and see what we're looking at. So this is the same piece of code as what I just showed. We are returning 1 if all of the numbers passing are positive. We are returning 0 for 0. We're returning -1 for negative. So for this list of numbers we're passing in, what should we return? Give me some reactions, please. What should we return if the weights array is like this? So we return 1 if all of them are positive. We return 0 if there is 1 0. We return negative if there is 1 negative. And we return the first one that we encounter. So what should we return if the array looks like this? negative -1. And let's see what it actually does. We see a warning, but there's no error, so I'll continue on. Check numbers. If it's hard to see on the screen. It returns a 1. But we're expecting a -1. Go to makefile, there is one command that does the warnings. You can disable warnings using this by changing warn flags into nothing. And if we do, we have to make clean first. And if we do make again, we see that there is no comments, no errors. And by removing the warning flags means we're removing comments and we're seeing a 1, which is a wrong answer, right? But if we actually look at this warning, what do we see? We see suggest parentheses around assignment used as truth value. And this refers to line 11 if weights I equals 0. So this gives us a hint of what's going on. We're using assignment here. So it's not a Boolean comparison, it is an assignment. So that means we're missing equal sign for Boolean. Let me re-enable the warning flags. And make again, we see no warnings. And we see -1. This is just to show how important warnings are. Do you not have any warnings in your code? Your TAs will be counting the number of warnings, and that's also one source of mark deduction. Keep your warning numbers at 0. And that is because warnings will flag potentially problematic code. Even if your code can run successfully, it can silently give you some wrong answers. If you leave some warnings in, it is hard to see new ones. So even if some warnings are not important, like your program will still run with no problem. But if there is one new warning that flags some problematic code in it, it's going to be really hard to see if it's buried inside warnings. So try to stay at 0 warnings. And your makefile that we give you always have all of the warnings turned on using the warning compiler flags that I just showed in the makefile. This is WALL means warning all warnings. And there is the number sign compare warning. And this one gives you a warning whenever you compare a signed number with an unsigned number. All of the warnings we consider useful are turned on in your makefile, so you don't have to worry about them. You just have to eliminate all of them. All right. Next one, group related data into classes. This is something that we don't force you to do, but it's good to have. In here, we have 4 vectors, all called something of segment. And down here, we make a class, or we can make it a struct called segment data that consists from intersection to intersection, speed limit, length of. And we do a single vector that consists of this class. This is a really good practice because it helps with readability and it reduces name pollution. So whenever you create a new global variable, you'll have to make sure that the name doesn't appear anywhere else. And you have to make sure that you're calling it the right name. But if you group it like this, it's adding one layer of hierarchy. So it's more structural and you only have to call segment info, and whenever you add a field, you can just do segment info dot name of field. So it's really easier to understand. That's grouping related data into classes. And by grouping, it really adds in structure, which is a good thing. The last thing is defensive coding. This is something optional, but is really good to have. And using enums, as we saw in the previous example, is also one type of defensive coding. We're making sure that only certain ranges of number can be returned from that function. Defensive coding, usually we use assertions to do it. So whenever this function finds three segments of intersection is called, we want to make sure that the global variable is already loaded before this is called. So we add a one-line assert into it. So we want to make sure that the intersection ID is greater than or equal to 0 and is less than the number of intersections. And we want to make sure that the intersection street segments dot size is not 0. So there is something inside this global variable. And this is the assertion message. After adding this assert, this program will terminate as long as this function is called without initializing or called with some intersection ID out of range. So instead of giving out random wrong answers, this will terminate right at the point where it detects the issue. It's better than a comment. It checks at runtime and it gives useful error messages. At runtime, if you see something like this will be telling you that the program crashed, where it crashed, and which assertion made it crash. The syntax looks like this. You'll have to include assert.h. You'll have to do the assert. And before include assert.h, you can add in this flag here called ndebug. This will turn off all of the assertion checkings, and this will make your program run slightly faster. Because assertion also takes time. Only do this right before submitting or right before running the auto testers. Any questions for assertions? Other than assertions, this is something that you always have to do with pointers. Whenever you delete a pointer, set that pointer to null immediately. Unless you know for sure that this this pointer will not be reused by anyone else. Because this pointer might be a shared pointer with someone else, might be reused by someone later. So setting it back to null is a really good practice, because if anyone is getting hold of this pointer afterwards, if it's not set to null, it will randomly access some memory that does not belong to you. So if you set it back to null, when you do this, will segfault immediately, and you know something is wrong here. Is this clear? Is this good? Everyone knows why we need to set it back to null? Yep. Setting it back to null will segfault immediately. Without setting to null, you'll be accessing some random memory that does not belong to you, and you'll read in probably a lot of garbage values, or you'll be corrupting the memory space. That's not good. Last one is the advanced technique of self-checking code. We want to write validation as you go. And this is advanced techniques, and we don't expect you to do it. If we do not use assertion or validity checkers and let the program fly on, you'll probably see something like this. We don't want the error to propagate all the way to output. All right. All right. The last demo is on assertion and the end debug flag. I'll close this. What's this? This is optional, but it's a good to have. Like, you won't use marks not using it, but you'll probably get bonus mark if you use it for all of the functions you needed. But it depends on your TA. Okay. Okay, this is the code that we just factored out and fixed all of the variable names. I will add assertion right at here. Whenever this function is called, I want to make sure that the intersection ID is within the range, and we want to make sure the global variable is set. So, as in the slides, I will do include assert.h. That's the header file for assertion. And I will be doing assert intersection ID is greater than or equal to 0. And intersection ID is less than our global variable, which is intersection street segments dot size. So this checks for two things. First, intersection ID is greater than or equal to 0. Second, intersection street segments dot size is not 0. And intersection ID should be less than the total size. If any one of those is wrong, this assertion will fail. Oh. And I want to go to makefile. I want to make sure it works first. It doesn't break anything. ECE297 exercise 1, run tester. functionality and intersection. This doesn't break anything.
Something was wrong, and I think the assertion of the statement was false in the brackets. What would happen?
If the statement is false in the brackets, the program will crash at once and it will tell you which assertion failed. I'll show you as the next thing. So I want to download this tester for debug. So what I changed was I changed run tester to debug tester. And I will ignore everything here because this is on debug. What this gives you is under libstreetmap tests, it will give you 3 new files. And we want this M1 functionality intersection, Toronto, Canada. These are the source code for the actual public test that we just did. So these are some global declarations. This is the first test suite on intersection street segment that we want. And if we scroll down, we see there are 2 other test suites that we're not worrying about so far. And I will be deleting them. This is my local copy. This doesn't affect any global tests or anything. This is my local copy, and I want to. All right, I'll run this first to make sure that it's still passing. Because I'm not doing any debugging, I'll still keep the release mode and the build target to all, and I want to change the launch target to test libstreetmap. That is the launch target we use to run the tests that we actually have. So build with no problems. There are some warnings that are not related to us. And now I can do run. And this runs this one test in this file, and it gives us the test time. Now I want to randomly change one of these to an impossible number, -1. So to make sure that the assertion is a false, I change this. I can do a build and assertion failed. This is what you see when the assertion is failing. It will tell you it's in m1.cpp line 64, m1cpp line 64, and it's this assertion. We'll see that this assertion is in this function, and we know there's something wrong either with intersection ID or the intersection street segments. And if you want to look into it more, you can, before the assert, let's say output both values and see which one failed. Or you can split this assertion into multiple ones and see which one failed. And now, speed-wise, if we have too much assertions, this will slow things down. So before you submit or before you run the performance tests, what we would recommend is do this, define and debug. This will turn off all of the assertions, as we just said. Right. Assertion is turned off and we see one test failed. I'll back to here and you should see it passing again. Right. That's it for assertions, and this is a summary of today's topic. Keys to maintainable code. Your code will be read more than written, either by you, by others, or by others. So make sure it's readable both to you and to your teammates and for the TA. Your code will be modified many times so make sure when you modify it, you won't be introducing new bugs. Bugs are not avoidable, so try to maintain a good coding style can avoid most of the bugs. It will only get worse if you don't maintain a good coding style. Keep the tests with the code. It's better if your code can crash right on the spot, right on where a problem happens, than when your code gives a wrong answer after the bug propagates all the way into your program. So make sure your code is testing itself as it goes. It will get harder and harder to debug the further the bug propagates into your program. Keep the documentation in the code using comments, using good variable names, and do code reviews. Code reviews can be painful, but because it's a collaboration project, you have to work with other people, so you will have to review each other's code and make sure everything is consistent, everything is clear, everything is good. And there is the project management and code style rubric that you can refer to. Your TAs will be deducting marks or giving bonus marks according to that rubric. All right. Additional resources, there are books, there are talks, and there are online resources like the Google style guides. Usually, if you follow everything here, you should be fine. And follow everything we discussed in this tutorial. All right, that's it. Any questions for me? Yeah.
When you provide scope, checking for global variables, or do you usually use it other times?
So for the assertions, you want to, like, the purpose is for you to make sure there's nothing wrong at this running time of the program. And this checks at runtime. So technically there is no rule of making assertions. You can make assertions on anything. In this case that we showed, in this case, when this function is called, because the person who writes this function has no control on who calls this function and who's calling this function in which way. So we want to add the assertion to make sure that this parameter here is making sense. And this also is applying to this one, the global variable, because the person writing this cannot make sure that this one, the population of this one does not get commented out or skipped in the load map. Probably especially if someone else is modifying it, right? So this is something that's good practice when you are developing this program.
Also, do we have to have everything finished by next week if our real or practical is Monday? So, I think the deadlines for the functions are a bit late.
I think the auto tester's deadline is on the deadline, but if you need to meet with, like, the practicals are for you to meet with your TA. And the grading session is 1 week after the deadline.
Oh, it's after?
Yeah, but your TA will be grading on your project management each week when they meet with you.
But the main grading will set everything and the code.
Yeah.
After.
Yeah, the grading itself happens 1 week after. Yeah.
Like, you know, like, and that means there's like this vertical line I don't know if you've seen that, like that, I think it's supposed to tell you, like, don't make your code like too long.
Yeah.
Horizontally.
Yeah.
We also have to follow that.
You don't have to, but it's good if you follow that. We worry more about the vertical spacing, vertical length
Yeah.
than the horizontal. But horizontally, if you go after that line, you should be careful. You could probably split into temporary variables or doing something else to make it more readable. Because if it gets too long horizontally, there is a sign of something's getting too long. Yeah.
Say like how many percent goes towards the dimension coding practice?
The rubric should have something like that. The rubric. For milestone 1, because all of the mark from the TA goes into this. So for it's going to be larger portion in milestone 1 than other milestones. Yeah. But for all of the milestones, there are some portion of the mark going into this. So make sure you follow this. Yeah.